All right, line P3, low voltage transformers. We are still working our way through learning task 2, which is a super long learning task. And right now we are moving to our last major set of transformer connections, and this is going to be delta to Y. And it is going to go and be where we have got an input into the delta side, and we're outputting out of the Y side. What we do want to also point out is that we are creating in a delta to Y, whether we're doing delta to Y step down or delta to Y step up, we are going to be creating a Y type of system, which means that it has a neutral, which means that by Canadian electrical code, we must ground it. We create the system, it is our responsibility to go and ground it. Once again, we are going to be looking at two distinct, just like in the previous videos, two distinct connections that we are going to go and have. They're going to be repetitions of the previous video, except now we're going to be feeding into the delta side and feeding out of the Y side. It should be a little bit easier now to get your head around the whole concept of where we're building these little phasor diagrams from. And once we create those phasor diagrams, we're just going to go back into that same connect the dots type of situation. Delta to Y, we have got a high voltage delta down to a low voltage Y, which is one of our delta to Y connections where we are using this thing as a step down type of transformer to deliver a lower voltage onto a Y type of system. The other one that we are going to be taking a look at would be where we're coming in as a lower voltage delta, and then we are stepping up and coming out as a higher voltage Y type of system. So we're going to examine both of these inside of the video. The very first one that we're going to go and take a look at, though, is we are going to go and take a look at this one over here, which is where we have got, one second, let's erase that, where we have got our feed in on the high voltage side, the delta, and then we are feeding out onto the low voltage side. I do want to note that on both this one and the subsequent drawing over there that you should be noting that 30-degree displacement that was put in last video. You noted that there was a neutral and that our A to neutral was 30 degrees off the horizontal on our high side, and then that we took that A to neutral that was existing and we moved it up by 30 degrees. So that my A to neutral was a 30-degree displacement from my low side, from my high side to my low side. And the same with this one over here. We would have had the exact same layout, A to neutral. And then right over here on our delta, we have got that neutral. This is where A was. This is where we are moving A up to B. So we're always looking at that sort of a rotation that's going to go and happen in these. Okay, the first one that we're going to go and look at is going to be this, where we have got a high side delta and where we are going to go and have a low side Y. So we're going to start by dividing this down. We are going to go with high and we are going to go with low, H's and X's, and our high side is delta and our low side is going to go and be Y. Start with our fundamental rules, which are that draw from the high side first, start at point A. Once you have created point A, you're then going to go and take two measurements off of it. You're going to do a 30-degree measurement, which is where your neutral would be, and a 60-degree measurement, which is where your B is going to go and be. So we're going to go and draw in the B. We have got the neutral drawn into the center over there. We can remove those lines, and then we're going to go and place C. So far, the same. Always, always the same. It doesn't matter what connection we're doing. We're going to do it like that. It is a delta. There is no connection to neutral, but neutral itself does exist. There is an electrically neutral point that is balanced between the three phases. We are now going to go and make our connections. We always have an H1 of the associated phase that is going to go and be on each one of these connections, our A phase, B phase, and our C phase. So we've got our H1 over there, and then we just go and connect the dots. Remember that the 1s are the tails and the 2s are going to go and be the heads of these vectors. So we're going to start down here, and I'm going to draw that arrowhead in. Remember that these arrowheads are now really important to us. The B phase, same deal, and the C phase, same deal over here. Once I've got all of those in place, I can go and put my H2s off of everything. H2s and H2s over here. And now I'm going to go and draw in my low voltage side, and I'm going to have to look to go and make some parallels. Now, before we draw in the low voltage side, let's just set out where A, B, C, and neutral are going to go and be. We know that initially on our high voltage side, we had an A to neutral that was 30 degrees off, but now that we have to move this thing up by 30 degrees. So our new location for A is actually going to be up here. Actually, I wanted to go with my red marker and right away mark that in as being a red A. So we know where that A is, we know where our neutral is, and then we know that the rest of these marks, B and C, are just going to go and be rotated around here. A to B to C, going around like that. Then what we're going to do is we're going to go back to our high voltage side, and now we're going to go and draw in our low voltage windings. Our low voltage windings are always in parallel with our high voltage windings, or at least the phasors are, I should say. So we draw them in, tails and heads over there. So now that we've got those laid out, the next thing for us to do is now transfer those low voltage windings over to our other side. So we take this one, we're going to carry this one over, we're going to look for a place where I can fit it. Obviously it doesn't connect from neutral to A, it doesn't connect from neutral to C. The only place where that one could go would be neutral to B, so I'm going to drop it over there. I'm going to grab the next one, do the same thing, I'm going to carry it in. A to neutral, it doesn't fill that line. This one's already filled, and it does fill my neutral to C. And we'll grab the last one over here, carry it over, and we see that these two are both filled, plus it wouldn't work in either one, so therefore it's going to have to go across like that. And now we have got our Y type of connection over here. Remember that the ones are going to be the tails, and the twos are going to go and be the heads for each of these. So now that I know that, I can go and place in my connections. My lines, so I'm just actually going to go and erase this neutral point here in the very center, and we'll just extend these out just a hair over here, just to make that actual connection. Okay, and then we are going to go and make all of my tails ones, so these are going to go and be X1s and X2s, X1, X2s, and wrong color over there, X1s, X2s. Beautiful. Okay. We've got all of the X1s, all of the X2s that are now laid out onto this diagram. This is once again that really, really weird one where on the low voltage side, we're using the C phase over here to go and feed the A line. We're using the A phase to go and feed the B line. We're using the B line, our B phase, to go and feed the C line that we are going to go and have off of that. The other thing that we should note is that we are going from delta to Y, and we are creating a Y, which means that we are going to go and ground that transformer as well. Okay, let's jump past a couple of diagrams over here. We're going to jump past diagram 47 and 48 because those are just showing how we arrived at what we were just doing over there. 49 and 50 are going to be for the alternate one. We're going to jump all the way over here to my diagram number 51. The next couple of diagrams are just going to go and show the same connections as what we are doing over here. We're just going to draw them in, walk over them as we go through, and then we'll just verify that they line up with everything else. A line, B line, C line. Remember that we are feeding in off of this top over here, and then that we are going to be feeding out on the bottom. I'm going to go A, B. Actually, let me just verify and see which ones they went with, because sometimes they change the orders, and then that gets a little bit weird looking when you're comparing one. So A, B, and C. Okay. And then we're going to place a neutral as well because we're going to be creating a neutral out of the system. Okay, we're going to go back up to our diagram that we just made, and now we're just going to play paint by numbers once again. We're going to start with doing our high side over here, and if we take a look at my A, I see that my A line connects to my H1 of my A phase. So let's go down there. My A line connects to my H1 of my A phase. Going back through, B, H1 to the same one, C, H1 to the same phase. So we'll just quickly check those ones in there as well. The B, H1 goes to its phase, and then the C, H1 goes to its phase over here as well. Taking a look then back at our diagram, we see that A, the H2 connects over to B. So the A winding completes on B, B winding completes on C, and C winding completes on A. So we're just going to go back and do the same thing. The A winding is going to go and complete on B. The B winding is going to go and complete on C. And the C winding is going to go and complete on A. Over here, we've got our standardized connection in. It's a delta one, so we just check all of our lines. And we're just going to do that real quick count. 2 connections, 2 connections, 2 connections. Therefore, this whole thing is good to go. Let's take a look at our low voltage side. We're going to start by taking the easiest connection that we have, and the easiest connection would be for me to go and use all these X1s. We're going to grab all of those X1s and we are going to go and connect them on. So X1 of A connects to neutral, X1 of B connects to neutral, X1 of C connects to neutral. And because we created a neutral, therefore we must go and ground it as per Canadian electrical code. So we'll throw that ground onto that one as well. Then we're going to go back up here and we're going to see that the A line receives the X2 of my C. So we're going to go back and we're going to do these just one at a time. The A line receives my X2 of C. So we're just going to go and carry that down to here. Okay. My B line receives the X2 of A. So my B line, this one over here, receives the X2 of A. And then my C line receives the X2 of B. My C line receives the X2 of B, like that. And that's our connection. We have got a 3-phase bank, additive polarity transformers, all connected up over here. I'm going to just do a quick little double check. I see that I have got 3 connections onto this neutral. That's a good Y. And I see that each of my lines have only got 1 connection each. That's a good Y as well. The next couple of diagrams that they had inside of here show the exact same thing as what we just did over here, where we had all of these connections through all of the X1s, the high voltage side, standard, the X1s connected to the neutral, X1s connected to the neutral, and X1s connected to the neutral. And then we saw that the C line was feeding A. We saw that the A line was going to be feeding B. And we saw that the B phase was going to be feeding C, like that. And so we had all of our connections in. Okay, it is the most confusing one for us to go and have to draw, just because of the fact that we have got the C phase transformer that is feeding the A line. But as far as the actual vector addition goes, this whole thing does go and add up, and it works well. We get a proper 3-phase system that does proper 3-phase things. Okay, the next connection that we're going to go and take a look at is going to go and be an easier one. It's going to be this one over here, where we are now going to go and have we did a delta to Y step down, and now we are going to go and do the next one, which is going to be a delta to Y step up. And it's a delta to Y step up, but we have to go and start by building our diagram always from the high side. So we're going to just go down here and we are going to go and make a new diagram to start this one out. Delta to Y, step down. Oh, sorry, yeah, I did skip a couple of other diagrams. Figure 54 just shows that we can do the same thing with subtractive polarity transformers. Figure 55 shows that we can do the same thing with mixed polarities. Go through both of these, double check, make sure that they have got all of the lines onto the correct ones. Make sure that there's no mistakes inside of them. If you know mistakes, email me and tell me about those mistakes that you have found. But don't just believe all the connections that are inside of this book, as we saw in the previous video there. Okay, we're now going to go and work on a step up transformer where we are going to be feeding in on the delta low side and going up to a Y high side. And to do that, we need to go and build one more phasor diagram. So let's go and grab a blank page over here. I'll just duplicate this one here. Perfect. Okay, so delta to Y was done. Now we are going to go and do delta to Y step up. And because it's going to be a delta to Y step up, we need to rebuild this thing delta to Y step up. And this time we're crossing over from the delta to the Y, from the low voltage side, the X's, to the high voltage side, the H's over here. Which side do we start building on? Well, we always start building on our A side. Drop in that A, make those two lines, the 30-degree line to where the neutral needs to be, the 60-degree line to where the B phase needs to go and be. And once you got those two in, we can erase those two lines. Once we know where A and B are, we can go and create C. And now we're just going to go and play connect the dots going over, and we're going to go and place H1s on each of these lines. H1, H1, and H1. All of those lines are connected in. Now we can go and make the connection. We're looking to create a Y type of connection, so we're going to be bringing everything over to the neutral. A phase comes into the neutral over there. B phase comes into the neutral over there. C phase comes into the neutral. Remember that we are going to be creating this neutral, which means that we're also going to have to go and ground it. Anytime that we create a neutral, we must ground it by code. And now we can drop in the remaining numbers. We can go and drop in our H2s, and H2s over here. And now that we have got all of our high voltage side done, we can go over to our low voltage side. And we know that the low voltage side, that we have this phase displacement. A to neutral looked like this on the high side, but on the low side, because we're changing from Y to delta, anytime it's a different delta to Y or Y to delta, we have to move this thing up by 30 degrees. So we are now going to go and end up with it over there, which means that my A is going to go and be over here. That's where my A is, continuing around in a clockwise manner. I'm then going to go and place my B, and I'm going to go and place my C as well. And now we are going to go and create lines to go and parallel everything. So I'm going to go and draw my low voltage windings in, smaller arrows that we're going to go and place for each one of these. Smaller arrows and smaller arrows. We'll do some lasso selections of this one here. We'll just grab that one, and we're going to carry it over, and we have to fit it in. Does it fit there? Nope, doesn't fit that line. Does it fit here? Absolutely it does, between B and C, because I see that B and C has to be a vertical line for where these things are lined up. So I'm going to drop it right there. We're going to go in and we'll grab another one. We'll grab this one here, the C winding, and I'm going to say, does it connect the line from A to B? Nope, it doesn't connect anything inside there. Is it lined up with A to C? You bet it is. And we're going to do the same with my A. The only place left, this one is taken, this one is taken, the only place left is A to B. And if I take a look, it definitely does align with that. Now that we know where those arrows are going, or where those windings are going, we know that this side is going to be a 2, this side is going to go and be a 1, but they're going to be X's. So we know we're going to have an X1 and a X2. Same with my B's, X1, X2s, and same with my C's, X1s and X2s. With that all in place, we're just going to redraw these arrows so that they actually, connect up, make it look like a real connection over here, and like so, and like so. And we have got our delta connection in. For us now to make this connection, all that we need to do is we need to go and carry these connections out and do that whole connect the dots thing one more time. Let's do that. This case, we are now standing once again on this side. Remember that anytime that we're looking at a transformer bank, here I am standing, I'm always going to go and see the A on the right-hand side. So I'm standing, I'm looking at the high voltage side right now. Normally we've had the highs on the top, now it's on the bottom, so we've just endoed this whole diagram here, flipped it 180 degrees. Okay, so I see my A is on that side, my B over here, my C over here. I'm just going to go and give these things just a quick little squiggle so that we don't screw these things up here later on. And now we're just going to go and play connect the dots. We're going to start with our high voltage sides. And we see that looking at my diagram over here, my high voltage, all the H2s have to go and tie together. So I'm going to go and do that. I'm going to go and connect all of the H2s together. H2, H2, and H2. And then the last thing that I'm going to do now that I've created a neutral is I must ground that neutral. Going back to my diagram here, I see H1s to A, H1s to B of the B phase, H1 to C of the C phase. So we are going to go and do those lines. H1 to A of the A phase, H1 to B of the B phase, H1 to C of the... So that completes our high voltage side, the Y side. We're now going to go and take a look at our low voltage side, which is going to be the delta side that we're feeding in on. And once again, I see that the X1s of every phase connect to that proper line. A phase connects X1 to A, B phase connects X1 to B, C phase connects X1 to C as well. So we're just going to go through and make those connections. A phase connects X1 to A, B phase connects X1 to B, C phase connects X1 over to C over here. All of those connections are good. We go back through and we see that the A terminates on B, B terminates on C, and C terminates on A. So we're going to go back through. We're going to go and terminate. A terminates on B, B terminates on C, and C terminates on A, like that. And this is our complete connection. Verify that you did all the connections together, you know, that they all look good from one to the other, and you should have a perfectly fine connection at that point. And you can verify what we just did here compared to what they have inside of their book. Ours just, once again, has colors, and theirs doesn't have the colors. This connection was done all with additive polarity transformers. Subtractive polarity transformers is perfectly doable as well. Same deal on the high voltage side. All the 2s are going to the neutral, and then the C, remember that we're on the opposite end right now. C goes to C, B goes to B, and A goes to A. And then on the low voltage side, my X1 of A goes to A, my X1 of B goes to B, my X1 of C goes to C, and then A terminates on B, B terminates on C, C terminates on A, like that. Perfectly fine to use subtractive, and perfectly fine for us to go and use mixed polarities. When we are using mixed polarities, because we're viewing this now from the high side never mixes. Anytime that we have mixed polarities, it's always seen on the low side. So I note that all of my H2s still the same. All of my, C and C, B and B, A and A, that all stays the same. But what I'm going to see is I'm going to see everything change over on the opposite side. If I take a look, I see that I have got crossing over here. That means it's additive. Over here, I've got direct line. That means subtractive. And over here, I've got crossing over. That means it's going to be additive. And we just go and follow. A, the X1 connects over to line A. B, the X1 connects over to line B. C, the X1 connects over to line C. And phase A terminates on B. Phase B terminates on C. And phase C terminates back on A. And that gives us our proper complete setup that we would need to have for this one over here. Okay, now that we have got all of our connections together, the very last thing that we are going to do is we're going to go and double check for our values of voltage. And really what we need to do to test on these ones, because we're creating that Y system, is we are going to go and test line-to-line values of voltage. You don't need to test the line to neutral voltages, you can, but as long as you go and get E-line, and E-line all the way across, you're going to be completely fine with these systems. As soon as you get something that isn't reading proper line voltage, that means that you've got that nasty little chicken's foot. We saw that one in one of our earlier videos, where if you flip one of these around, this one should be up over there for a Y type of system, but if you connect it incorrectly, you end up with this chicken foot, and you end up with these weird little voltages that are going to be inside of it. Okay, that is it for these.